What's up guys, back again already. Time now for the Ferrari SF90, called the SF90 to celebrate the 90th year of Ferrari in 2019, and this is a car that is very much an evolution. And we talked about that a little bit with Mercedes. Perhaps that's natural when you're leading the field, when you're at the front. You don't want to be too revolutionary, you don't want to throw out the concepts that have worked for you. It's about refining those, tidying them up, tweaking them a little bit and looking for tiny improvements here and there. The idea of marginal gains very much apparent in this particular car. Let's have a look. I've got a mixture of real pictures and digital renders, digital images that the team have sent out. The real pictures from the launch tend to corroborate the fact that the digital renders were reasonably accurate. But we've got a mixture of two to highlight some of the technical areas that I think are interesting. Now the first thing perhaps to say, or that's strikingly obvious on this, is the front wing. Very similar in many regards to the Renault solution in terms of front wing. And by that what I mean is the fact that they have chosen to go very, very high on the inboard, the full height allowed on the inboard section of these elements, but then swoop down very, very low at the point where it meets the end plate. Almost flattening out the sort of outboard edges of each of these flaps, all in a bid to create or regain some of that outwash that was lost from last year. I'm not going to go into huge detail about that because I think we've done it to death on pretty much every car. But that's the idea here, less so on some of the others. Some of the others have utilised the maximum height all the way across here in a bid to generate downforce. Ferrari looked like addressing more the downforce side of this front wing and more of the outwash control, flow control elements of the front wing. Very similar nose cone arrangement that lots of the others have gone for. Very different, quite obviously, to what Mercedes have done, where Mercedes have got a very narrow nose cone. Ferrari have the full width or a wider nose cone with the two extended supports back here, trying to push through that channel the airflow into the centre section of the car. The front suspension, you can see, again, very different to that of Mercedes, where they have taken the different concept of lowering the suspension arrangement as much as they possibly can, and you can clearly see from this picture why they've done that. They've raised, and this is the idea that Ferrari kind of pioneered back in 2017, of raising up the inlet for the side pod as high as it can possibly go, pushing down the structural crash structure member here and turning that into a winglet by pushing that down and raising that opening up high, and then correspondingly pushing the suspension down as low as it can go. You can clearly see that the inlet from the side pod has got a very clear stream, free stream of air rushing towards it, which essentially improves its efficiency. It becomes easier to ram air into that particular part of the car. You can see how the suspension element is not quite horizontal but almost horizontal, and yet it disappears into the wheel. If you think about the Mercedes car, it's mounted much higher up at this point, and correspondingly, because it runs horizontal, it's mounted up higher at this point on a little sort of extended, where's my pen? Somebody told me off yesterday for pointing with my finger because my hand gets in the way. So look, here's the pen back. On the Mercedes, the wishbone comes out across here and then is mounted on a sort of extension, little arm extension here, to keep the wishbone up as high as they can. On the Mercedes, to try and drive airflow through the middle. Ferrari have just taken a different solution to that same problem by pushing the whole lot down, opening up the stream or the path towards that inlet there. Brake ducts, relatively standard, with some vertical serrations inside there, or separators inside there. There may well be a mesh. Quite often there's a mesh, a little wire mesh or filter mounted to the front of those to stop leaves and bits of visor tear off going in, so that at pit stops they can be easily cleaned out by the mechanics. One of the things that I'm not sure is too obvious from this picture, but I think will become clearer on another picture, like many others, they're using the support brackets on top of the wings here to help direct the channels of the airflow. But on this one underneath, it seems to be quite a few mounting points along the wing on the underside, which are almost acting like flow conditioners on the underside of that wing, just helping to channel the airflow to the places it needs to be. But there seems to be quite a few between the lower two elements, sort of all the way along here. Okay, looking from above and at the side then, you can clearly see what I'm talking about here, that 1, 2, 3, 4 and then 1, 2 at least of these little mounting brackets on the underside here. In the past we've had many strakes mounted underneath the front wing. Nowadays we're only allowed 2 of those, but they're all designed to help clean up the airflow, and I suspect that's what they're doing by putting what I would probably say are an excess number of mounting brackets, support brackets under here. You probably don't need that many in their support function, but in their aerodynamic function I guess they're helping by having more of them there. You can see that the end plate, again maximising the outwash effect by taking advantage of the biggest curve they can get within the regulations, and a nice long full length foot plate as well. The end plate just drops down ever so slightly, so the height of the end plate at the trailing edge slightly lower than the height at the front edge, and that's something that we haven't seen on many other cars. But in conjunction with this lower point where all the front wing flaps converge on the end plate, it's just helping to generate this outwash, helping to encourage the flow through this direction, through a lower cutout on the top of the end plate, lower mounting points on the wings, means that all the airflow is rushing towards this corner point, and with the flick out on the end of the end plate there, it's all designed to wash out this way and drag with it that horribly messy, turbulent front tyre wake. You can also see in this picture, again something that Ferrari have had in the past, had that last year, serrated mounting brackets running all the way up here, a little bit like the McLaren, but a slightly more extreme version. Not a full cape back here, but a similar concept. Instead of the cape running all the way back like it does on some of the others like the Mercedes, they have got a sculpted, much shorter cape here, but it's doing exactly the same thing. These 2 tunnels either side of the thumb tip of the nose are all designed to push the airflow rapidly through, squash it through that small gap, speeding it up, again drawing it in through these slots on the side here, and then pushing it under that shortened cape and out into this really busy and really important section back there. It doesn't show up very well on the picture, but there is a little inlet on the side of the nose cone around here, which is the S-duct inlet, dragging airflow in through here, through a S-shaped duct in the centre of the chassis, and exiting just out here at the top of the raised, the slanted point of the nose cone. I've talked about that before as well, but that's about aiding the attachment or retaining the flow attachment to the surface of the bodywork. As that rises up at an angle, as the angle changes, it would be quite easy for that flow to detach and become messy and turbulent. So if they can inject some high energy air out of the S-duct, it will aid the attachment and continue to keep it attached along the top of the bodywork surfaces. So some quite nice intricate work there, but very much, as I said, an evolution of what they've had in the past. The Bargeboard area, like many of the other teams, certainly the bigger teams, very busy, lots of intricate detailed work going on, many vertical and horizontal split strakes, a big large area footplate, a little bit like we saw on the McLaren, a shadow plate on the base there, almost an extension of the floor just to give more surface area to control that airflow as it starts to move backwards towards the rear of the car. Vertical strakes here, we saw that on the Red Bull as well, in a tiny little gap between the chassis and the bargeboard. There's a little area within the regulations where you are allowed to have this higher section. The regulations have pushed the bargeboards much lower and further forward, but there's a tiny little gap which the teams are starting to exploit with very thin, very narrow extended pieces of bodywork off the deflector, the bargeboard there, to help condition the flow along the side of the chassis to be worked around this area. So lots of work going on there, all designed to push the airflow along the sides of the chassis and this outwash that's coming off the front wing away from the front tyre. Up here we've got that raised side pod inlet, cooling inlet, as I said before, something they've done in the past, split into different sections. That'll be channelled off into different areas within that bodywork for different coolers. The bodywork around that, again an evolution of what they've had before, a big sculpted vertical wing on the end connected to the wing mirror, so the wing mirror mounts again here and here being used for aerodynamic benefit, as most of the teams are now starting to do. This big winglet on the side here just creating a channel which this airflow running along the inside of the deflector of the bargeboard gets sped up and forced through this channel, which then energises it and passes it through the contour of the bodywork and into this undercut area here, where the top of the floor and the rear of the diffuser really works it very, very hard. The floors are looking very, very similar in concept to most teams. They're all starting to converge now on very similar solutions. Diagonal splits here, as I talked about the other day, to manage the squirt of airflow that comes out from the tyre where the tyre meets the racetrack. The airflow at that point squirts out here, but it also squirts out that way. And if it goes underneath the car, it can really interfere with the flow of the diffuser. So these channels here are to create a series of vortices rather, which will protect that and run around the inside of the tyre, sealing it off. The longitudinal strakes, or slots rather, running all the way along here, which you see on most cars now, again designed to seal up the outside edge of the floor, protect that from any unwanted intrusion of air. So quite nice. This bit here, very different I guess to last year, different shape, much more triangular air intake. The other teams and even Ferrari had a much more oval shaped intake last year. Small details these are, and it's something that they've clearly worked with. It also allows them to shrink in the bodywork at either side of that, so the rear end of the car essentially can be a little bit narrower and therefore less draggy at that point as well. As long as they can get enough airflow into that for the turbo intercoolers and other cooling parts of the car that's connected to. As long as they can get enough in, of course that's fine. The engine of course needs enough air as well, but as long as they can achieve that, it allows them to slim in the bodywork, and of course for aerodynamic benefit that could well be an advantage. We can see at the rear here they have got again something we've seen before, but a sort of double T-wing, full width, looped around all the way around in a sort of oval shape at the rear, just ahead of the twin rear wing mounts. Quite high up is the actuator for the DRS. Bigger DRS flap of course this year, but the actuator remains the same. Looking at the rear of the car then, you can clearly see high rake concept like many of the other teams have followed. You can see, this is a digital render, bear in mind, but you can see that T-wing, that looped over T-wing off the back here, the double mount for the rear wing. There is the actuator for the DRS. Great big bulbous shroud covering that hydraulic actuator that sits inside, able to pop open that rear wing flap as and when it needs it. Very similar, but perhaps a few more vertical strakes at this area of the wing where it opens out from the narrow section to the wide section. Lots of teams have followed this. Vertical strakes on the trailing edge at the bottom edge too. What I've seen here, it's not very clear from this picture, but they've got three very narrow upturned sort of winglets, if you like, or strakes on the side of that end plate, all designed to create an upwash or aid an upwash. The upwash that comes off the rear wing anyway is quite powerful, but that's generated by a differential in pressure, with the airflow having to speed up and rise around the really curved section of the underside of a rear wing. The top surface of course not quite so curved, and because that becomes high pressure on top, low pressure underneath, that's what pulls the car down onto the floor. But the airflow following off that, having risen up around that very curved underside, ends up firing up in a very much upward trajectory. As that pushes upwards, of course the car is pulled back downwards, and to aid that upwash effect, these three little upturned strakes on the side will just help the airflow that's transitioning off the side of the end plate here to mix with that really high energy airflow, upturned airflow from the rear wing. What can happen is that the airflow on the other side of this end plate, the airflow that's passing over the rear wing, which is hugely energized by the effects of that wing, can induce some drag when it mixes with the boundary layer, that's the layer that's very, very close at the point of the end plate, which is being slowed down of course as it passes over the bodywork. So the boundary layer very slow on this side, on the other side of that wing very fast moving air. When the two leave the rear wing end plates, of course, we used to have lots of horizontal strakes, didn't we, up in this corner to help bleed between the two, to help that transition and to reduce drag. And these are just one little attempt, minimal attempt, but within the regulations that's pretty much all we can do. Just one little attempt to help with the upwash, to help reduce any drag and reduce the transition between the sort of more horizontal airflow, linear airflow here, and the upturned airflow on the other side. So some nice little details. As I say, very much an evolution rather than a revolution. They were close last year. Not all because the car wasn't good enough. The car at times last year was definitely good enough. So these are little tweaks that they of course hope will make the difference. I think what's going to make the biggest difference at Ferrari is the way the management structure has changed, the way the team has sort of reset. Brand new driver pairing, of course, with Charles Leclerc coming in, who I'm very excited to see up against Sebastian Vettel. This is one of the most exciting developments for me in terms of car, driver, team management. It's a new look Ferrari. Is it going to be a Ferrari that can really take the fight to Mercedes for the entire 2019 season?